You gotta choose. You gotta choose. You gotta choose it. Here. All right, lady.
Thank you. Or-
Yeah, so that Viking, you see that Vikings cup up there? You don't have to ask, you can just go grab it anytime you can. Okay. So here's the game plan today. I'm going to go over 6 problems that I made up a while ago. Remote students, you do not have this sheet of paper. So like a blank sheet of paper will do just fine to follow along. There's paper right up there, Chris, so that you can grab that we're working on, okay? So you don't have this paper here. So just go ahead and just do it on a blank sheet of paper to follow along, okay? And then after that, there's blank sheet of paper or that sheet of paper right there for you. And then when we're done with these 6 problems, I'm just giving you work time to get done the CFA, okay, the 5.4 CFA, the 5.4 extra practice, and then obviously the 5.4 like regular practice if you haven't done that already. So after these 6 problems, it's essentially a work day. Because we have to be good at this to be able to do the next stuff. So I need you to go ahead and do that. Yeah. Yeah. Well, I had originally, that was going to be your Friday work, but we don't have remote Friday for this section right now. So we might come back to it. Maybe we'll do it next week or something, but as of right now, no. Okay. Yeah, I'll have to take that down. And then what other, but I want this, I do truly want the CFA done though. This is an important, if you can't tell, it's an important section. That's why we're spending like a week and a day. So, I need, so obviously you need the cheat sheet out. Okay. So again, we're just working on the same types of problems. I just want to give us plenty of practice, especially when the instructions are not clear how to factor. All they say is just factor completely. Okay, so when I'm doing number 1, okay, every problem starting with this, and that is taking out your greatest common factor. Okay, does anybody identify numbers? Okay, 4. Does 4 divide into 26? I don't think it does. So 2 for sure. What about a variable? X. So we're going to take a 2x out of here. Okay, so 48 divided by 2. And then there's x cubed, and I'm dividing out 1x, x squared. They're equivalent statements. Yes, that's right. Okay, then 26 divided by 2 is 13. X squared divided by x. Okay, negative 4x divided by 2x, negative 2. there's sheets of paper on that, right up there, that's what we're on right now. Okay, so that's greatest common factor. Okay, after this point, we actually have to figure out what method do I need to use to factor this. Okay, so here I'm going to cover up the greatest common factor because I'm no longer concerned about that. You ask yourself the question, how many terms are there? 3, there's 3 terms. Does my A value equal 1? No, it doesn't, so I have to use the Xbox method. This is the longest method. Actually, synthetic division will be the longest method. Okay, A times C is going to go down here, so 24 times -2. And then the B value is going to go up top, which is 13. So I need numbers that multiply to -48 and add to 13. One of them is going to be, I mean, I don't know what this is. So I'm going to just write up 48 here. Okay, so the first combination is 1 times 48. Is 1 times 48 going to add me to 13 one way or another? Okay, so then the next one is going to be 2 and 24. That can get me to 26 or to 22. That's not it. Does 48 divide by 3? It does? Okay, so then that's probably the combination then, right? Does it really multiply 48 times 16 is, okay. I'll be dang. Okay, so yeah, this can get me to 19 or to 13, right? Can get me to 19 or to 13, and we're trying to get to 13. So which number is going to have to be positive and which one's going to have to be negative to get to positive 13? Yep, 16 has to be positive, which means the 3 has to be negative. Okay, this is exactly what you should do if you have no idea what that combination is. You're guaranteed to get the combination eventually, assuming that you did everything else previously correct. So we get 24x squared here. We get -2 here. -3x here and 16x here. Okay, where's my negative going to come out at? Bottom left for how I wrote it. Okay, based on the way I have it written, it's going to be bottom left. Okay, I no longer have to think about negative. Okay, I just have to start taking greatest common factor out. So greatest common factor between 2 and 3. 1. Greatest common factor between 16x and 24x squared. Okay, 4 definitely divides into both of those. I think I'm seeing one that's a little bit larger. 8. 8 divides into each of these. Okay, now there's another really good way to figure this out because the greatest common factor here is a little bit easier, right? 3x and 24x squared, what's the greatest common factor there? 3x. Okay, and so then if you didn't know that this was 8, well, I know 3 times something is going to have to get me to 24. Well, that's going to tell you it's going to have to be 8x. Okay, and then lastly, 16 and 2. 2. So this factors into 2x times 8x minus 1 times 3x plus 2. Okay, try not to forget that this is a factor itself and it needs to be brought down with it. Well, we should get in the habit of checking to make sure each factor cannot be factored further. But none of these are perfect squares. None of these are perfect cubes. So we're good. Well, 8's a perfect cube, but x is not a perfect cube. So. Okay, let's do number 2. Number 2, again, we start with the same thing over and over and over again. You're not listening if you cannot answer the question of what do we do first. Because it's greatest common factor. What's greatest common factor here? It is x. So I'm going to take an x out. And if I divide 8x to the 4th by x, I get 8. And then x to what power? 3rd. And then if I take x and I divide it by x, what do I get? 1. Anything divided by itself is 1, even if it's a variable. So here I'm dividing x by itself at 1. Okay. So now I've taken the greatest common factor out. So then you ask yourself the question, again, just following the flow chart. Eventually, I'm going to start taking the flow chart off of this and just start talking. How many terms are there? There's 2. Okay, so I have to try to identify special patterns. Just by looking at this and not looking at our cheat sheet, you think we're going to look for cubes or squares? Cubes, because the x is a cube. Okay. Specifically, if I'm looking at my 3 different special patterns, am I going to look for subtraction of cubes or addition of cubes? Subtraction. So let's go ahead and check. Is 8 a perfect cube? Yes, it is. What's its root? 2. So I can rewrite this as x times 2. What's the root of x cubed? Yep, the cube root of x cubed is x. And then what is 1 a perfect cube? And what's its root? 1. Okay, so now I have an a value. And now I have a b value. Okay, so now even for myself, I still need the formula for these because I do not have the cube ones memorized. Yeah. It is -1, but the way I kind of organized it here, it's just a positive one here, like minus whatever this is. It's kind of arbitrary, but essentially. But here's the thing: I'm like keeping my negative sign, so I haven't like changed anything, right? Because I've kept my negative sign here. Okay, so here I have my a value and my b value. I just have to plug my a value and b value in here. So I'm going to keep that original x. Okay, a minus b. So my a value is 2x, so 2x minus my b value, which is 1. Okay, then I have a squared, so I have to square all of a. So that's squaring all of a. That's why I have like double parentheses there. Plus a times b, 2x times 1. And then plus b squared. Yeah. No. You just have to identify what your shortcut is. I, in general, will probably always show you every single little individual step. You have to figure out where you can and cannot shortcut. Like for myself, if I was doing this problem on a test for myself, like I would probably not write this step because I know 2x squared. Well, that's 2 squared. Two times 2 is 4, and then x is x squared, right? And then 2x times 1 is 2x. And then 1 squared is 1. So like for myself, if I was doing this problem, I probably would not ever write this step. I would just go straight to here. But for some people can do that. Some people can't do that. So, you know, gotta find what works. Okay, now you have to remember this part here looks like it can be factored. But if you use a special pattern and you've taken the greatest common factor out to begin with, this second part is always completely unfactorable, meaning it's done. Three. Obviously, we're starting with. Okay, anybody identify greatest common factor? So if I divide 4x squared by 4, I get x squared. If I divide 32x by 4, I get 8x. And if I divide 80 divided by 4, that is 20. How many terms are there? 3. Does my A value equal 1? So this means I'm looking for the values that multiply to C, which is negative 20, and add to B, which is 8. Okay. Now, technically, for what I actually think this method is the easiest method, but some people, for whatever reason, really don't like this. You can technically, for this one here, if you want to use the Xbox, you can use the Xbox still, okay? It's all the same. All right, but anyway, does anybody identify numbers that multiply to negative 20 but add to 8? $12 and 8 multiply to 96.
10, negative 2.
10 and negative 2. So 10 times negative 2 is negative 20. 10 plus negative 2 is 8. So my combination is 10 and negative 2. Since that's my combination, my factors are going to be x plus 10, because that's a positive 10, and x minus 2, there's a minus 2. So I think a good helpful thing here is like try to figure out the numbers that multiply first, and then the adding part will figure itself out. Questions on 3? Four. We should know where to start. X squared is the greatest common factor, so I'm going to take an x squared out. So if I take an x squared out, I get 4x squared here, and then I get 49. Yep, minus 49. So I'm looking at this, I'm subtracting. It's 2 terms. I've already taken the greatest common factor out. I got to look for a special pattern. I think I'm going to look for squares or cubes here. Squares, right? When you see x squared, it's a pretty big hint that you're looking for squares, right? So is 4x squared a perfect square? It is. What is the root of 4x squared? 2x. The root of 4 is 2. The root of x squared is x. So now I have an a value of 2x. Is 49 a perfect square? It is. What's its root? 7. So I have a b value of 7. Okay. So again, I know I look for squares here. Okay. So this is what I have. I figured out a and b because those are my roots. So I just plug a and b into the right-hand side here. So it's just going to be 2x plus 7 times 2x minus 7. I'm just going to do this just so we can get adequate time, I guess. That's a big word. Appropriate, I guess, would be an appropriate amount of time, a reasonable amount of time. I mean, we're looking at everybody's going to get an hour just to work on homework right now. So homework and CFA, that is. Let's do 5. Okay, greatest common factor. No, right? 7 is really the number that gives away to me. Like, not a lot divides into 7. It's just 7 and 1. That's not even the lowest number. So, okay, so we figured out no greatest common factor. The next thing we need to ask yourself is how many terms are there? There's 4. Then I need to ask the question. Remember, we haven't done this one a ton. I think these ones aren't too bad, though. It's going to be in the form ax cubed plus bx squared plus cx plus d. I need to ask whether b divided by a is equivalent to d divided by c. So is negative 7 over 3, is that equivalent to 28 over negative 12? It is. Okay, so they're all both 2.3. I'm just gonna get a calculator quick so everybody can see. You don't have to be great with fractions to do this. You can just go ahead and say, you know, -7 divided by 3, well, that's -2.3. And 28 divided by -12 is the same thing. So they are equivalent. Okay, knowing that the answer to that is yes, it's true. That means yes, we can use the box method. Okay, box method is the second easiest one, I think. It's easier than Xbox because it's one less step, essentially. So I'm going to use box. Set up the box, and then you just take out greatest common factor. Okay, greatest common factor between 3x cubed and 7x squared. I'm looking at, well, 3 and 7. The only numbers that divide into 3 are 3 and 1. The only numbers that divide into 7 are 7 and 1. Yep. So that tells me that 1 is the number. 1 has an x squared, 1 has an x cubed. That means I can take an x squared out of each one, right? Two of the x's. What about here? Greatest common factor. This one does not have an x, so we know we're not taking an x out. I think -4 here, right? 12 and 28. 28 divides by 4. This divides by 4. Other numbers that are larger, like 6 divides into 12, but it doesn't divide into 28. 12 divides into 12, but doesn't divide into 28. So it is a -4 here. This one's going to be negative also. I should have done that because that's kind of how I've been teaching it. Is, you know, if you look here, we have negatives in our corners. So we're going to take negatives in our corners out. So we should have done that before, but it shouldn't be that big of a stretch here. Okay, here's 7, and that makes sense because -7 times -4 is +28, so that's good. And then here, 3 and x. And again, that makes sense not only because this is the greatest common factor, but also because 3x times x squared is 3x cubed. So I have this. Okay, especially when you're factoring any other terms that aren't special patterns, like these two have been special patterns so far. Anytime you are not using a special pattern and you get a binomial with an exponent, you should at least check to make sure it is a perfect a special pattern. Okay, there's two terms. X squared is clearly a perfect square. Okay, so we need to check whether 4 is a perfect square. So go ahead and take your sheet out, take a look. Is 4 a perfect square? It is. Realistically, 4 is one that you should have memorized as a perfect square. Okay, so I can actually factor this further. What is the root of x squared? What is the root of 4? So now I have an a value, which is x, and a b value, which is 2. This is going to factor into 3x minus 7 times x plus 2 times x minus 2. And just following that special pattern cheat sheet. It only gets worse. It's been especially bad. I think the mask does not help. It is what it is. All right, number 6, greatest common factor. No greatest common factor. There's 2 terms, so we want to identify special patterns. X cubed, clearly a perfect cube. What about 1? Is 1 a perfect cube? It is. This is one that people often miss because it's so subtle, I guess. I don't know how to put it. Innocuous, maybe. Like it just, I don't know. People forget that 1 is a perfect cube. It's also a root. So this is the sum of cubes, right? 1's a perfect cube, x cube's a perfect cube, and we're adding, like we're going to use this bottom one here. We just have to figure out the root of each of those so we can plug it in. Okay, the root of x cubed. X. The root of 1. Also 1. So now I have an a value, which is equal to x, and a b value, which is equal to 1. So then I can plug into the formula. The formula says, and I'm just reading it right off the paper, a plus b, which is x plus 1, times a squared minus a times b, plus b squared. Okay, then I can just say x plus 1, x squared is simplified, minus x times 1, that would just be minus x, and then 1 squared is 1. And again, we got this second part from a special pattern. If you've done everything correctly prior to that, that means that that part cannot be factored. You just don't have to worry about it. Probably like a week from Monday, Tuesday. So not next Monday, Tuesday, but the week after that is kind of when we're thinking testing. Because if you have 5.4 down, 5.5 and 5.6 are essentially the same section. And I really do not think it's like that much harder. If you can do synthetic division, which I think most of you can, then hey, if you got this factoring part down, the rest should be easy peasy. The only thing that is going to suck about it is sometimes the problems are long. It's not that big of a deal. Okay, this is what I want you doing today. Okay, try to make sure you have the 5.4 homework done, the 5.4 extra practice. I really would like 5.4 CFA done, so I can just kind of get a sneak peek of like who is still struggling. Okay. Or maybe nobody's struggling and we're just kicking butt. Okay. The people who actually have this, like the backside was a quiz because that originally was going to be your Friday work. But we're not remote Friday anymore for this section. So we're just hang on to that sheet. We might like come back to it later, but there's also a real chance that we don't. So essentially the backside says something about a quiz. Feel free to just kind of forget about that for the time being. All right, so yeah. Remote students, I guess, I don't have, I mean, if you just use this time just to get homework done, you know, realistically, this should probably be done already, but I understand that that's not necessarily the case. So just work through those 3 things. Those are what I'd like to see done over the next 50 minutes or so. If you want to stay on, feel free to stay on. If you want to log off to get your stuff done on your own, feel free to do that as well.
Okay, bye.
Just so you know that this CFA is not, I mean, this is regular CFA, it's not counting for the assessment grade. So do your best on that. You know, trying to make those CFAs aware of assessment grade. You gotta let me know if you need questions. I just gotta get attendance real quick. You're on help out.